Yeah, you'll see the time. Hi, good morning everyone. Right, so we're dealing with revision for test 2. Remember, it's 70% of the syllabus. And so don't only concentrate on what we were doing last week, which is analytical geometry. A lot of the test is the first part of the question paper here, which is factorization, exponents. You can see that. And this is simple. I think everyone must get full marks here. And with this analytical geometry, it's just using a formula, substituting, working out the answer. Right, so let's deal with this one here. Simplify without using a calculator. So now, we look for the simplest base here. That's 3, which cannot be broken down any further. But 9 can be simplified. It can be rewritten with a base of 3. Right, so how can we rewrite 9? 9 will be what? 3 squared. So I'm rewriting 9 as 3 squared. It has to be in brackets. If there's no brackets, it is wrong. And this is half x minus 3 to the power x minus 1 all over 3 to the power x plus 2. Now, what do we do here? We have a power raised to a higher power. Can you see that? So when you have a power raised to a higher power, if I have x to the power a raised to the power b, what you do is you write down your base, which is x, and power raised to a higher power, multiply the exponents. So that will be a times b. So that's exactly what we need to do then. So if I write down my base, which is 3, I will multiply 2 times 2x. Right. Minus 3 to the power x minus 1, 3 to the power x plus 2. So now, what will happen here is simple. We don't need a calculator for 2 times 1 over 2. 2 and 2 cancel. You end up with just 3 to the power. 2 and 2 will give you 1. So that will be just 3 to the power x. Right. Now, we cannot cancel anything here. Why? Because there's a minus sign separating the terms. Can you see that? So there's 2 ways to go from here. One is to split up your exponents, which is a common way of doing it. So if I split up my exponents, 3 to the power x times 3 to the power minus 1, in the bottom, this will be 3 to the power x times 3 squared. Split up your exponents, take out a common factor. So what is my common factor on the top?
3x.
It will be 3 to the power x. What am I left with now? If I take out 3 to the power x, I have to be left with the number in front, which you cannot see, which is what? Which is 1. So that's 1 minus, this will be 3 to the power minus 1. In the bottom, that's your 3 to the power x, 3 squared. So now, it's all multiplication, so now it is possible to cancel. Before, it was not possible because of the minus sign separating. Alright, so these 2 cancel. Let's see what happens. You're left with 1 minus 3 to the power minus 1 is 1 over 3 to the power 1. We must understand the exponent law there. If you have x to the power minus n, this can be written as 1 over x to the power positive n. If you take the base to the bottom, the sign will change. If it was a negative, it changes to positive. Right. So now, all divided by, here we got 3 squared. Now you got 1 minus 1 over 3 now. Right, you can work it out. You don't have to show every step with that in the test or the exam, but Without a calculator, we are subtracting fractions. So when you are adding or subtracting fractions, what do you need to find? You need to find your LCD. So what is my LCD here?
3.
What is it going to be?
3.
3.
1 over.
So 1 will be 3 over 3 minus 1 over 3 all over
Swap this.
3 squared. So now I got my LCD there of 3. I can write it down one time only, and then 3 minus 1 will give me 2. So that's 2 over 3 divided by 3 squared, which is 9. Right. So now what do I have? I have a fraction divided by a fraction. So how do I work this out? I copy down the top fraction. And what does the division sign change to? Multiplication. Remember, this is 9 over 1 at the moment. 9 is 9 over 1. So, what will it change to? 1 over 9. So now what happens here? I've got a fraction times a fraction. So, top times top, bottom times bottom. So 2 times 1, that will be 2, 3 times 9 will be 27. I don't think we can simplify this any further. So there will be 2 over 27. Alright. Any problem here? You must be familiar, you must have done many examples like this, right, which we have done on Saturdays. Before test 1, we dealt with many examples like this. Simplify without using a calculator. This is 5 marks. Right, so what's common here in the numerator? I can see that there's a square root everywhere. Can you see that? So the square roots can be written as, you got 27 there. Rewrite it in exponent form. That will be 1 over 2 plus log 8 to the power 1 over 2 minus log 125 to the power 1 over 2. Well, here in the bottom, at the moment, there's nothing much we can do in the bottom. Can you see that? Now, what I can do here is, I can bring down my exponents. Right. I can bring down my half, so that's going to be half log 27 plus 1 over 2 log 8 minus 1 over 2 log 125. All divided by log 6 minus log 5. What can we do now? If you look at 27 now can be written as 3 cubed. 8 will be 2 to the power 3. 125 will be 5 cubed. Right. But then, if we do that, we will still have to bring down our exponent anyway. Okay. So now let's try it in a different way. Right. If I take out a common factor there of half, so if I take out half as a common factor, what am I left with now? Log 27 plus log 8 minus log 125, all divided by log 6 minus log 5. Now,
Sorry, sir. Why do you have a power of half
when?
in the first step?
In the first step?
Yes.
The square roots. Say if you have a square root, that's x, a, b. Right. If I have to rewrite this in exponential form, that's going to be x to the power a over b. So if I have the square root of x, or let's say if I have x here, that's a 5, that's a 3. And you see your a and b here. Right. If I want to rewrite this in exponential form, let's look at this one first. Because here you can see your a is 5 and your b is 3. Can you see that?
Yes.
So all you do is you will write down x and you will convert this to an exponent, which is a fraction. Numerator will always be the power, which is 5 in this case, and the roots will always be the denominator, which is 3. That's straightforward, right? But now when you have the square root of x, you cannot see the numbers here. The numbers are not shown. Can you see that? So if the numbers are not shown, then the power, if there is no power, what is it always? It is 1. If there is no root shown, like here it's a cube root. If there's no root shown, it's automatically just 2. Right, square root. So when you change it, it will be 1 over 2. So that's why the square root of 27 is 27 to the power half. Can you see that? Right. Now, let's get back here. Let's see what we can do here. Right. I'm trying it out in a different way from which I did before. So now notice my bases are the same here. Can you see that? My bases are the same. That means I can combine the logs. I can write down the log one time only. It's only allowed if the bases are the same. Write down my log one time only. Write down my base. The base is not shown yet. But what is the base automatically? It's 10. So if you want to, you can write it down. What does plus change to?
Negative.
Plus will change to multiplication, the times. So that's going to be 27 times 8. And what does a minus change to? So that's going to be divided by 125. Okay. And here I got log. Again, my base is the same. Can you see that? So I'm combining the log. I'm writing it down one time only. And that will be, okay, let me write down my base again. Combine the log. Write down log once only. Write down your common base once. So that will be 6 over 5. Now, 27 times 8 divided by 125. What will that be? You see what's going to happen here? Okay, let's leave out the calculator. Let me show you what's going to happen. Right, what I can do. 27 times 8 divided by 125. Right. If you look at your exponent block, if I got a to the power n times b to the power n divided by c to the power n, I'm multiplying and I'm dividing it. Can you see that? But what is common? What do you see that's the same?
N.
It's the exponent n. Can you see that? So now, what I can do is I can multiply and divide the bases a times b divided by c, and I can put a bracket and write down my exponent once only. Can you see that? Now, it's important to know your timetable, know your powers, know your cubes. Now, when I look at this here, straight away I look at 27, I look at 8, I look at 125. There's something that's common there. Right. So if you look at this, I'm not showing you this law for nothing. Everything I write down for a reason here on the board. Okay. So now let's look at 27. We got 27 times 8 divided by 125. What do I notice now? That 27 is actually 3 cubed, 8 is 2 cubed, and 125 is
5 cubed.
5 cubed. Can you see that?
Yes.
Now look at this and look at what we have here. Can you see that? So now, that means I can apply this law, multiply and divide the bases. So that's going to be 3 times 2 divided by 5.
All
And
roots
I will
of
write down my common
cubed.
exponent of what?
3.
Of 3. Can you see that?
Yes.
Exactly what I wrote down there. I just copied it down here now. So now, let's do it here. That's going to be log. Okay, let's do it properly here now because this is what you're going to be copying down. So now this is going to be 3 cubed times 2 cubed divided by 5 cubed, and it's all divided by log 6 over 5. Now, I'm sure you can see now what's going to happen from here to there to the next step. Let's see. That's going to be 1 over 2. I got log. Refer to what I wrote down here. So that's going to be 3 times 2, which is
6.
6 over 5, all raised to the
Cube.
power 3. Can you see that? Here's it here. 3 times 2, 6 divided by 5, all raised to the power 3. And it's all divided by log 6 over 5. Now, what do you think I'm going to do next? You look at this straight away, you can
Common
see
factor.
log 6 over 5 on the top, log 6 over 5 in the bottom, but it cannot cancel at the moment because it's not the same. Right, it's almost the same, but not exactly because
The cube.
this has a 3 there. Can you see that? So can you get rid of this 3?
Split to the front.
So all you do is, from your log law, remember, what did we do here? We brought down the half here. Can you see that? So I can bring down my 3 here, so that's going to be half times 3, and then I got my log 6 over 5 divided by log 6 over 5.
Log 6
And now
over
what
5
will happen
cancels.
here?
Log 6 over 5 cancels off.
These are identical, which will cancel. Can you see that?
Yes.
So you end up with 1 over 2 times 3. 3 times 1 is 3 over 2. Now, not the only way of doing it. Right, it is not the only way of dealing with this question, yeah? But I'm looking at it without a calculator. What you could have done also was, in the beginning, you could have written down 27 as your 3 cubed here, 8 as 2 cubed, 125 as 5 cubed. Right. And then it would have worked out much easier that way. But anyway, copy this down. Check now. Take out your calculator. The question says without a calculator. But now after you work it out, take out your calculator. Type in this whole thing. Press equals to. Check. Do you get 3 over 2? If we do not, then there is a mistake somewhere. We need to correct it. Do we get 3 over 2? Yes. That means there is no mistake. Right. Without a calculator, you have to really understand your laws. Let's see if we can cut it into half. Now remember, I just showed you, you got the square root of x, that's a, that's b. This can be written as x to the power a over b. Right. So now, 27 can be written as 3 cubed, 8 can be written as 2 cubed, and 125 can be written as 5 cubed. Can you see that? So now what I'm doing is, I'm changing it inside. So what will happen here? This will be 3 to the power, what is the root here? That's not shown. That's a 2. So that's going to be 3, which is a base, and that's going to be 3 over 2. Here your base is 2, and that will be 3 over 2 again. Here, what is your base? That is a 5, and that will be 3 over 2. Can you see that? Remember, there's a 2 here. So that's 3 over 2, 3 over 2, 3 over 2. Now what I can do is, I can bring down my exponents, which is 3 over 2 log 3 plus 3 over 2 log 2 minus 3 over 2 log 5 all divided by log 6 minus log 5. Right, now I can take out my common factor. Can you see the common factor here? It's 3 over 2. So if I take it out, I am left with log 3 plus log 2 minus log 5 all divided by log 6 minus log 5. Which is equal to 3 over 2. Well, there's many things I can do now. Log 3 plus log 2. What is log 3 plus log 2?
Log 5. Log
What's
5.
log of 3 plus log of 2? If I give you log of A plus log of B, what's log A plus log B?
Log AB.
Log of A, B. Because what does the plus sign change?
It's multiplication.
Multiplication. So if I ask you, what's log of 3 plus log of 2? What is it? Log of 6. So that's going to be log 6 minus log 5 on the top, log 6 minus log 5 on the bottom. Because log 3 plus log 2 is log 6. Can you see that? So now I got log 6 minus log 5, identical. Numerator, denominator, cancel. So your answer is 3 over 2. Right, it was not a simple example, so you had to apply your log laws properly. Right, let's deal with the next one here quickly. Factorize as far as possible in prime factors. Right, so factorize, how many terms do you see?
2, 3.
3 terms here. Terms are separated by the plus
Or minus.
and the minus sign. Okay, so you've got 1, 2, 3 terms, you've got a square, so this is a trinomial, a quadratic trinomial. It's in the form ax squared plus bx plus c. Right, now, only difference is that x is no more x is now x minus 2. So, if it was 2x squared plus 9x minus 5, how would you factorize this? 2x squared plus 9x minus 5, that's your trinomial. Open up your brackets. 2x squared can only be 2x times x. Then you look at the 5. 5 is only 5 times 1, but where do you put the 5? Where do you put the 1? Is it a minus 5? Is it a plus 5? What's it going to be?
Minus 5.
That's where you have to write it down and actually check. There's no magic to just write it down one time. You write down, you try out. If it doesn't work, your middle term doesn't work out, then you try out another factor. Okay. So, if I put down a plus 5 here and a minus 1, I'm taking a guess. Alright, let's see if my guess is right. Is that right? Yes. Why is it right? You have to check it. Check. 2x times 5 minus 1 times x. check if you multiply it out, do you get the middle term? 2x times 5 will be 10x minus 1 times x will be minus x. 10x minus x is equal to 9x. So now, if you look at this example and look at that, it's almost the same. Can you see that? The only difference is now there's not just x there. In place of x, there's now x minus 2. So you can do it in one step if you want to, or you can use a substitution. If you want to do it in one step, you have the answer here. All you do is now replace x. What is x? X minus 2. So that will be 2 into x minus 2 minus 1, and this will be x minus 2 plus 5. Is that my final answer? I need to remove the brackets and work it out. Let's see what happens. 2 times x, that's 2x. 2 times minus 2 will be minus 4 minus 1. Here, minus 2 plus 5 will be plus 3. So 2x minus 4 minus 1, that will be minus 5, and that's x plus 3. That's factorized fully. There's nothing more we can do here. Right. It's not necessary now for you. Some of you still use the old technique which takes too long. What you will do is, you got your 2 into x minus 2 squared plus 9 into x minus 2 minus 5. When you see a square, you square it. It will work out, but it takes too long. So if you have to square it, this will be x squared minus 4x plus 4. Then this will be plus 9x minus 18 minus 5. Then you must remove this bracket here. So that will be 2x squared minus 8x plus 8 plus 9x minus 18 minus 5. We multiply and multiply here for too long. Can you see that? So that will be 2x squared 9x minus 8x, that will be plus x, and what else do we have here? 8 minus 18, that will be minus 10, minus 5, that will be minus 15. And then from here, you factorize and you will get your answer. That's another alternate way, but it's not a smart way of doing it. Okay, because what happens if you have a question like this here? If I give you 2 into a plus b plus c plus d squared plus 9 into a plus b plus c plus d. Can you see how difficult it's going to be to square this now? And that's why you need to realize that this is a trinomial and it can be factorized. Right, but there's your alternate technique. From here, you can go straight to here. Let's deal with the next one. Plus 9x minus 5. Okay. You factorize. Here, it's no more x. It's changed into 2 terms here. Can you see that? Your exam paper will be similar to this here. Okay. Because this is the latest 2014 April exam. The students who, it's like we use it as a supplementary exam. And students who failed in November, last year they wrote this one here, the April exam. Okay. You can see, this is what you must expect, these type of questions. Right, let's deal with the next one. We don't want to waste time. Wasted too much of time on that log example. Right. What can we do? We got m minus n in brackets there. Times 36x squared plus 49ny squared minus 49. No, I think I didn't copy it down right there.
That's alright.
This is an m, am I right?
Yes.
That's m. Plus 49ny squared minus 49my squared. What do we do? Now, a common mistake is, you see brackets, you remove the brackets. Like, you see a square, you square it. Okay? Don't make that common mistake. This m minus n is already a fact, it's already a clue here. Okay, it's in brackets. It's a clue. Now, what you will need to use this clue to try and take out a common factor from these two terms here. Can you see that? So let's see what we can do here. Leave m minus n. Do not remove the brackets. So that will be 36x squared. Now, what is my common factor here? What common factor can I take out? Now, let's see what happens. If I take out 49y squared, because that's what you see initially, can you see that? If you take out 49y squared, what are you left with? N minus m. Can you see that? Now, what do you want in this bracket here? Basically, what you want is these two brackets to be the same. Then you can take out a common factor. But now, after taking out 49y squared, it's almost the same except for the signs. Can you see that? So, instead of taking 49y squared out, what must you take out? You should know the trick. We've done it many times. You take out minus 49y squared, and then n minus m will change to m minus n. Check it. Don't take a chance. Check it. Minus 49y squared times m is minus 49my squared. Minus 49y squared times minus n, negative times negative,
Positive.
will give you the positive there. Now, you can take out a common factor. Can you see that? I'll take out m minus n as a common factor, because now, let's look at it first. There was 1, 2, 3 terms. Terms are separated by the plus and the minus sign. Now, there's only 2 terms here. This is regarded as one term. This is one term, and there's a minus sign separating, so I can take out a common factor of m minus n. So what am I left with? I am left with 36x squared minus 49y squared. Is that my final answer? Be careful, this is an exam, these are exam questions. After you factorize the first time, most likely that is not your final answer. We already have one of the factors here. There's nothing more we can do with m minus n. But look at this here. Straight away, you look at 36, what must you remember? That's a perfect square.
Yes.
6 squared. 49? 7 squared. So this is the difference of 2 squares now. So that's going to be m minus n. Difference of 2 squares. I don't think there's anyone that doesn't know how to do the difference of 2 squares. At this stage, 31st of May, 2014. Okay, you've been here for how many months now? Difference of 2 squares, what will it be? This is going to be 6x minus 7y, 6x plus 7y. Now, there's nothing more I can do. That's my final answer. It was not easy. This whole paper is not easy. You can see that. Every question you have to work here. You can't just go one step right down the final answer. So the trick was here. There's always a question where you need to take out that minus sign. Because if you don't take out that minus sign, it's not going to work. You'll get stuck. You can't move from one step to the next. Let's move on. minus 12. This is the cubic function. It is not a quadratic where you open up your brackets. What you have to do now is find a factor. Substitute a value. Okay. When you substitute that value, you must get 0. Then, if I substitute 1 and I get 0, that means x minus 1 is a factor. You have to use the factor theorem now. Right. If I substitute 1 and I don't get 0, then I must try minus 1. If minus 1 doesn't work, I'll try 2. If 2 doesn't work, try minus 2. You got your calculator? You have to be fast. You're using it for many years now. Right, this is an exam. You cannot waste time in the exam. So you must be quick, you must be accurate. So, you find that factor.
How do you use minus 1? How do you work out minus 1?
Right, so what are you doing? What you can do is you can let f of x equal to x cubed minus 13x minus 12. We substitute 1. When you substitute 1, is it equal to 0? So that will be 1 minus 13, which is minus 12, minus 12, which is minus 24. We substituted 1, we get a remainder of minus 24. We must get a remainder of 0. So 1 does not work. And we try minus 1. Does minus 1 give you 0? Yes. So therefore, x plus 1 is a factor. Now, x plus 1 is a factor. So you have to use x plus 1 to find the other factors. Okay. Now, it's either you want to use the minus 1 and use synthetic division. I think I showed you on synthetic division last time. Okay, let me show you a long division now. Why am I showing you long division? People always don't like to use long division, but when you come to N5, when you deal with partial fractions, that's the whole of N5 and N6 is calculus. You have to use long division there to simplify something. So let's use long division now. How do we use long division? I've got my x plus 1 and I'm dividing into x cubed. Do I have an x squared there? There's no x squared, so it's actually a 0x squared. And I've got minus 13x minus 12. How do we use long division? Which I did in grade 4. Okay, I learned this in grade 4 and I didn't forget it. Long division. So that's going to be D M S B, which I'm also teaching to my N5 students when we come to a section on partial fractions. Right. So what does D stand for? Who can tell me what D stands for? D stands for divide. Have you done long division in school? Yes. Okay. What does M stand for? So that's multiply. What does S stand for? Subtract. But in my N5 class, not one person could tell me what does B stand for.
Brackets.
Everyone got it wrong.
Brackets.
Anyone know it?
Brackets.
What does B stand for?
Brackets.
Brackets. That's the same answer that my N5 students said.
Bring down.
B does not stand for brackets. B stands for bring down. Bring down. B doesn't stand for brackets here. B stands for bring down. Right, so let's just do that quickly. Alright, step one. Step one is divide. So you're going to take the first term, divide it by the first term. So what you're doing is, you are taking x cubed and you're dividing it by x. X cubed divided by x is x squared. The next step is multiply. The answer that you just worked out now, you will multiply it by x plus 1. So x squared times x will give you x cubed. X squared times 1 will give you x squared. So we divided, we multiplied. What is the next step?
Subtract.
Subtract. How do you subtract?
Minus.
These two terms minus the bottom terms. All you do is you put a division, you put a line here and you subtract. So that's going to be, the plus changes to a minus, the plus changes to a minus. Change the sign of the bottom term. What do we have? We have a 0 minus 1. What is 0 minus 1? That's going to be minus 1x squared. 1x cubed minus 1x cubed is 0. Alright, so we dealt with subtract. Now bring down. First time you're hearing of this word here. Bring down, let's see how you use it. You bring down the next term. You bring it down next to what you just worked out. Minus 13. That's how you use bring down. Okay. Now, you go back. You go back to step 1. You still can divide here. Can you see that?
Yes.
So now, what you're going to do is minus x squared divided by x. The first term divided by the first term. So minus x squared divided by x will give you minus x. Now multiply the answer that you just worked out here. Minus x times x will give you minus x squared. Minus x times 1 will give you minus x. That's multiply. Now subtract. How do you subtract? All you do is you change the sign of the bottom term. So that's a minus, which will change to a plus. Minus changes to plus. I advise you use a different color, otherwise when you go home, you'll get confused. You look at two signs, you don't know which one was there. Right. So minus 13x plus 1x. Minus 13 plus 1 is what? Minus 12. We got a problem with signs here. To go back to primary school now. Alright. So now, when the signs are different, we keep the sign of the larger number and you subtract. Which is larger from 13 and 1? 13 is larger, so keep the sign of the larger number. That's how we did it a long time ago. Right, that's how you subtract. And we've got no time now to do many examples on that. We subtracted. What's the next step? Bring down. Bring down your minus 12. And then you go back, because it's still possible to divide minus 12x by x. Can you see that? Minus 12x all over x. This is the last time you're going to be dividing. So what's minus 12x divided by x? Now taking minus 12x, you're dividing it by x. What are we left with? Minus 12. Multiply minus 12 times x, that will be minus 12x. Minus 12 times 1, minus 12. Subtract. Change the sign of the bottom term. Minus will change to plus, minus will change to plus. Minus 12 plus 12 will give us 0, 0. We must get a remainder of 0 at the end. Then you know you divided perfectly. There's nothing more to do here. Right. So, we use long division. We divided by x plus 1 and we found x squared minus x minus 12. So, let's answer this question. The question is factorize fully. So we got x cubed minus 13x minus 12. We factorized. What did we end up with first? We found x plus 1, remember? Then we use x plus 1, and what did we find? We found x squared minus x minus 12. Is that my final answer? This can be factorized further. Can you see that? Which is equal to x plus 1. 12 are we using? 12 times 1, 4 times 3, 6 times 2. Look at the middle term. Then, that is the clue. Are we using 12 times 1, 4 times 3, 6 times 2? Not everyone is confident on the 31st of May. Can you see that? How many months into the year? It's almost half the year. And you have to be confident in a simple thing like 12.